So, in our previous class, we have discussed about stopping set distance, and I told you that in in today's class, we'll solve some numericals on the stopping set distance. Okay, so let us solve some numericals, and I request you each and everybody to bring some paper and pen. Then it will be easy for you to go for the numericals. Okay, so your first numerical is calculate stopping sight distance. Calculate stopping sight distance for v equal to 50 km/h for two-way traffic in two-lane road and two-way traffic in single-lane road. Okay, so you have to calculate this. Now, how you are going to calculate? So first thing is you have that formula for the stopping sight distance. And what is the formula for stopping sight distance? That is SSD equal to V into T V into T plus V square divided by 2 GF. Okay, so that is the formula for your stopping sight distance, Vt plus V square by 2gf, as we have already discussed this thing. Now, in this formula, that V is in meter per second. So therefore, you have to convert that 50 km/h into meter per second. So are you calculating this? Are you calculating this? Am I audible? So how to solve this? First, you have to convert your yes. First, use the same formula and find out what is the stopping side distance. Formula would be same. First, you have to find out what is the stopping side distance using Vt plus v square by 2gf. Here, v is in meter per second. So you have to convert your 50 kilometer per hour into meter per second. So basically, it would be 13.9 meter per second. And your coefficient of friction value is 0.37, that is given in the question. And your t is basically your reaction time is, as per the stopping side distance consideration, it is 2.5 seconds. So first you have to find out what is the stopping side distance based on this formula. So it would be like 61.4. So stopping side distance when there are two lanes is equal to the stopping side distance, that is 61.4 meter. Now for a two-way traffic in a single lane road, it would be double of that stopping side distance. How it would be double? Because see, if it is a two-lane road, in that case two vehicles can be accommodated side by side. Suppose this vehicle is going in this direction and another vehicle is coming from the opposite direction. In that case, there are enough space through which they can uh, cross each other. Okay, but in a single lane road, what happens in a single lane road? That portions of the road is very much narrower and it can only accommodate a single vehicle. Okay, so therefore the driver need a more side distance, because here additional spaces are not available so that that vehicle can divert in position. Okay, so for this reason, for the two-way traffic in a single lane road, the side distance would be double of whatever you are getting. Okay, so for the stopping side distance, when there are two lanes road, it would be equal to stopping side distance equal to 61.4 meter. But for the stopping side distance for a two-way traffic for a single lane road, it would be 2 into stopping side distance, that is equal to 122.8 meter. So in simple words, all this initial formula would be same. That is Vt plus v square by 2gf. Okay, where g is the gravitational acceleration, that is 9.81. F is the coefficient of longitudinal friction. Here in the example, it is given as 0.37. Okay, and your v, you have to find out, convert that v kilometer per hour into meter per second, and you get the v as 13.9 meter per second, and t is your reaction time, which is given as 2.5 second. So first you have to find out the stopping side distance, and your stopping side distance is that stopping side distance is similar to the stopping side distance for a two-way traffic in a two-lane road. Okay. Now, for the stopping side distance for a two-way traffic in a single lane road would be double of whatever you are getting, because in a single lane road there are that type of road are less wider than the two lane roads, and only one vehicle can accommodate in that particular stretch of the road. So is it okay? Okay. So next we will go for the next problem. Next problem is find minimum side distance to avoid head-on collision of two cars approaching at 90 kilometer per hour and 60 kilometer per hour. So basically these two vehicles are coming from the opposite direction, and you need to find out what should be the stopping side distance to uh, avoid a head-on collision. Here your reaction time is given as 2.5 seconds for both the driver, coefficient of friction value is given as 0.7 and your brake efficiency is given as 50% in either case. In both the cases your brake efficiency is 50%. Okay, so you have to find out what should be the stopping sight distance to avoid a head-on collision for these two vehicles which are coming from the opposite direction. Now here one thing you have to notice, that here coefficient of friction value is given as 0.7 and your brake efficiency is given as 50%. Now the formula for the stopping sight distance is stopping sight distance equal to Vt plus V square divided by 2Gl. So in that formula, what are the parameters? That is speed of the vehicle. Okay, speed of the vehicle. If you go for the previous problem, that speed of the vehicles, reaction time, then again speed of the vehicle, then gravitational acceleration, and F is the coefficient of friction. Okay. So in this formula, there is no parameter which signify that brake efficiency. Okay, see in this formula, is there anything which is called as brake efficiency? No, but here brake efficiency is given as 50%. So for that reason you need to account that brake efficiency. Now how you are going to put that brake efficiency into that numerical? So basically your coefficient of friction is given as 0.7 and that coefficient of friction is basically between the vehicle tire and the road surface. Now if the brake efficiency is 50%, therefore you can consider that your coefficient of friction value is reduced by 50%. Okay, so if here brake efficiency is given as 50% and coefficient of friction value is 0.7, so ultimately your coefficient of friction value would be 0.7 into 50%, that is 0.5, that equal to 0.35. Is it clear? Is it clear? So if it is clear, then find out the stopping sight distance for both the speed. So you have to find out stopping sight distance for 90 km per hour speed and stopping sight distance for 60 km per hour speed. So find out the stopping sight distance for both the speed parameters. So when you finish the calculation for the stopping set distance for 90 and 60 kilometer per hour, then let me know.
Done, sir.
Okay. So how you calculated your F coefficient of friction value we have taken as 0.35, is it?
Yes, sir.
Okay. So in that case, your one value is coming around 153.6 and another value is coming around 82.2. Is it like that?
Yes, sir. Sir, 81.6.
Okay, 81.6 and another one would be around 152 or 153. Okay, so your total stopping side distance to avoid that head-on collision would be addition of both the side distance. Okay, so basically what happens here, two vehicles are coming from the opposite direction. So for one vehicle, total side distance requirement would be 153.6, and for the another vehicle, total side distance requirement for would be 82.2. So therefore total side distance to avoid that head-on collision required is addition of both the side distance, and that is 235.8 meter, or 235, around 235 meter, 236 meter.
Yes, sir.
Okay, now another thing is, when a vehicle is moving ascending or descending gradients, in that case what will happen? Okay, in that case what will happen? So let us discuss about the theory portion. So when there is an ascending gradient means when you are going upwards. Suppose that portion of the road is like that and you are going in this direction. Okay, that is your ascending gradient. So suppose that ascending gradient is n%. Now the component of gravity adds to braking action and hence braking distance is decreased. So if your L is decreased, in that case total side distance will also be decreased. Because if it is an ascending gradient, in that case you can your braking distance, that your distance travel after application of the brake would be lesser because you are going upward. Okay, so in that case your total stopping side distance would be lesser. So if it is n%, in that case your total side distance would be v square, that is your vt plus v square divided by 2g into f plus n by 100. Okay, because your ascending or descending gradient was n%. Now if you are descending a gradient, in that case descending means you are going downward, in that case your total braking distance would be increased. Okay, so in that case here braking distance would be v square by 2g f minus 0.01 n, or f minus n by 100. So for the ascending and descending gradient, your total SSD would be Vt plus V square by 2g f plus minus 0.01 n. Now let us solve this numerical. So in this case, see, find the SSD for a descending gradient, that is you are going downward, descending gradient of 2% for V equal to 80 kilometer per hour. So
Sir, formula for descending gradient.
yes, that formula is basically this one. Your Vt, as this is descending gradient, it would be Vt plus V square by 2g f minus 0.01 n. Okay, now here V is already given, T is already given, T is 2.5 second, V you need to convert this into meter per second, and N is given as 2%.
Sir, come see the question.
Okay, yes, see the question, and this one. Did you get the value around 131 or 132?
Sir, it's 127.7.
127. Okay, so that speed value you are getting like 22.22.
Yes, sir.
Okay, so your first portion would be 22.22 multiplied by 2.5, is it? V into T is equal to your 2.5 seconds, so your VT would be 22.22 into 2.5 second.
Yes, sir.
Okay, your next portion would be 22.22 square divided by 2 into 9.81 into 0.35 minus 0.02.
Okay, sir, I did 0.37, sir.
0.37.
37, sir.
0.37. Okay. Okay,
Okay, sir.
what is the coefficient of friction value you have considered?
Sir, I have considered 0.37.
0.37. Okay, okay, then it is okay. As here it is not given. Okay, you can consider 0.37. So if you consider 0.37, in that case you will get around 127 point something.
Okay.
Okay, now is it clear? That numerical is clear now?
Yes, sir.
Okay. Okay, now another type of side distance is there that is called headlight side distance and intermediate side distance. So basically, headlight side distance is required for the visibility during the night, and basically headlight side distance is equal to stopping side distance. Okay, and there is another term. It is called intermediate side distance. Intermediate side distance is provided where overtaking side distance cannot be provided. So in such cases, intermediate side distance can be provided in some cases. So intermediate side distance would be 2 into stopping side distance. So for the next problem, basically what you have to find, first you have to find your stopping side distance. After that, whatever stopping side distance you are getting, that stopping side distance would be equal to your headlight side distance, and if you multiply this with 2, in that case it would be your intermediate side distance. So up to this it is clear now?
Yes, sir.
Okay, so in that case we'll finish our class for today. In the next class we will discuss about the overtaking side distance, and we'll go for some numericals. So you can leave.
Thank you, sir.
Mm-mm. Attendance I have already taken.